Okay, question 1. Now then, equations you're always allowed to use. Okay, you can always use this one. Probability of A plus the probability of B minus the intersection is equal to the union. So every question you see here with the sort of Venn diagram style question, that equation is always allowed to be used. The other one is what you can always use is the given equation. Okay, so those two equations are always available to you. Now then, for part A, determine whether or not A and B are independent. The condition for independent, if independent, then the probability of A intersection B will equal the probability of A times the probability of B. That's the condition for independence, or if I'm told they're independent, I'm able to use it. And then part A is asking whether or not they are independent. So I've got to test that equation. So I'm given A, I'm given probability B and probability of the union. So I've got 3 of the values from this equation here. So I'm going to use that equation to calculate the 4th value, which is the intersection. So using that equation, substitute in probability of A is 0.2 plus the probability of B is 0.6 minus the intersection, which is what I'm trying to find, is equal to the union, which is 0.75. So just rearrange this, minus intersection on the left, take it over, so that's positive intersection on the right, and then bring the 0.7 over the other 5, so that's minus 0.75, so that's 0.8, take away 0.75, and that works out to be 0.05. Now then, to test this equation, I now know what the intersection is. I know what A is, given the question, I know what B is, given the question. So I test that. So I calculate probability of A times the probability of B, which is 0.2 times 0.6, which is 0.12. And as we can see that the intersection, 0.05, is not equal to PA times PB. So probability of A intersection B does not equal probability of A times the probability of B, therefore not independent. That's the first part. And then part B, find the probability that exactly one of A and B occurs. Now then, I've now got all the values I need to be able to draw the Venn diagram. So I'm going to draw my Venn diagram. The two intersecting circles. They round it, so that's A, that's B. We always want to fill in the intersection first of all, which I got is 0.05. Now the probability of A is 0.2, so the whole circle is 0.2. So I take away 0.05 from 0.2, so that part is 0.15. B is 0.6, all that circle is 0.6, take away 0.05, that's 0.55. And then to get the value outside, I total these 3 values, which is 0.75, so it'll be 0.25 outside. Now then, probability that exactly one of A or B occurs, that's the values which do not include intersection, so it's that part and that part. So part B, the probability exactly one of A and B occurs is 0.15 plus 0.55, which is equal to 0.7. First question. Okay, the second question Okay, this is a tree diagram. So we sell into 3 farms, A, B and C. So that's my first choice then, is which farm do I choose from. That's A, B and C. From farm A, 40% is a decimal, 0.4. Farm B, 35%, so that's 0.35. And farm C, 25%, that's 0.25. You can't put percentages on a tree diagram. It has to be either decimals or fractions. And then there's no 4% of eggs at farm A double yolked. So now I'm interested whether they double yolked or not. Let's just write line there. So either they double yolked or they not double yolked. Same choice for B. They double yolked or they not double yolked. And then for C, they double yolked or they not double yolked. Okay, so 4% in farm A, so that's 0.04. So the other value adds up to 1, so it must be 0.96. For B is 5% on B, so it's 0.05, 0.95. And then on C, it's 6%, so it's 0.06 and 0.94. Okay, now then, first part is find the probability that it's double yolked. So the probability double yolked. Now that can happen there, there, and there. So I'm going along there. So A in double yolked is 0.4 times 0.04 plus from B 0.35 times 0.05 plus 0.25 times 0.06. And typing that in on the calculator, that'll give me 0.0485. And then part B, right, this is a conditional probability. So it says given that. So when I open up the probability, put the bracket, put a line here, whatever I'm given comes after the line. So I'm given this double yolked. So I'm given this double yolked. I want to find the probability came from farm A. So that's why I want A given D. So to open that up, that's the probability. I replace that line with and D over the probability of what comes after the line, which is D, which is what I found out in the first part. So A and D, I go back to the tree diagram. Where do I see A and D? That's along that branch there. So it's 0.4 times 0.04 over the probability of double yolked, which I've calculated already, which is 0.0485. And if you calculate that, written as a decimal, that's 0.3299 to 4 decimal places. Okay, now the question then, that's part 1. Part 2 asks me to determine which farm it was most likely to have come from, given that it's double yolked. So I've done the fact that if it comes, given it's double yolked from A, so I have to work out the probability, same thing from farm D. So that's B and D over the probability of D. So B and D, that's 0.35 times 0.05 divided by D, which is, that's the first part, 0.0485. 0.85. So calculating that gives me 0.3608. And finally, do the thing from form C. C given D, that's C and D over the probability of D. So C and D is 0.25 times 0.06 over defective, which is 0.0485, and that comes to 0.3092. So the one which is most likely is the one with the greatest probability, which is form B. Therefore, it's most likely to come from form B.